Begin.
All right, perfect. Thank you, Jonathan, and welcome to those who have decided to attend this webinar. Thank you for showing your interest. Um, so a little bit about myself. We did get some of the information from John, but from me myself, I've been in the AEC industry or architecture field for I'd say about 6, 7 years now, and a little bit of historic preservation work for maybe about 2 to 3 years. So my prior position at the geotechnics company GBG allowed me to actually really dive into the world of BIM. Prior to that, I was more of a designer working for architectural design firms. But in that company, I really focused on doing BIM and also doing a specialized version of BIM, which was as-built modeling. And it was a very, very interesting and great experience, actually. And I learned a lot. So in the past, say, 2.5 to 3 years, I really, really focused on that. And so that's really what I'm going to share with you today is my experience in doing BIM in historic preservation. And I really feel like it's something that can be really useful, I think, to the field. And it's something that I've noticed that isn't quite well accepted or well known or well used yet in historic preservation. And I think that's why this webinar is something that needs to be put out there and is relevant and valuable to everyone. So thank you for having me, John, and let's kind of go through it and let's see what really is BIM and how is it really valuable to historic preservation. So let's take a look at. So I'm just going to start out real basic and talk a little bit about how has from the beginning of time basically how has the representation of the physical world been. And we use computers, we use lasers, laser scanners or distos or even tape measures. I mean, we're still using them in the field today. And really, those are the tools we have. But one thing about representation that I want to make clear, and everyone probably knows this to some degree, but really is that it's always partial. Whatever we're doing, whatever we're representing, whether it be a 3D drawing or 2D plan, there's information that's always not quite complete. And what I've really seen in the historic preservation field is that a lot of the information that people are getting to preserve buildings or think about renovating a part of a historic building is that many different contractors come in and they do their thing, whatever it is, and they make their representation, whether it be 2D plan, like I said, or a 3D image drawing or photograph. It's always a little bit disconnected and partial. So there's things missing, and it's up to the preservationists to kind of look at all that information and make the best use out of it. And I think that's really where I think BIM, as we're going to learn a little bit more about it, is going to help consolidate and make that task of management of all of that information a little bit easier and potentially more valuable. So again, some examples of those representations that we've seen before. I saw this all the time when I was in historic preservation. People draw plans, they draw these sort of, as you see here, it could be a hand drawing of a perspective view, could be even a photograph of the building itself or particular details inside the building or parts of the building, or even laser scanning, which is this top corner here, as you're seeing, is the output of what a laser scanner would output. And even though I think laser scanning is sort of advertised or is talked about as being really accurate, it has its limitations, and it only does what it can see. Any sort of interior details would not be able to be seen through a laser scanner, and you wouldn't even be able to discover it. So always, with no matter what tool you're using, the representation is always going to be partial. But you know, how do you combine all this information to make a more full kind of piece of representation that can be useful for historic preservation? And I think that's really where BIM comes in. So again, a little bit about my own personal experience. I worked at a geotechnical company, GBG, and during my time there, I mainly was a modeler. I took laser scan data of all these kind of classical historical buildings with very, very ornate details, and was basically bringing that information and modeling it inside of a BIM program. In my case, it was Revit. There are others out there. I think CATIA is another one. But right now, BIM, in terms of BIM, Revit is sort of the program that's being embraced kind of worldwide, at least in the AEC field. I see it happening on the contractors, construction. It's really being embraced. A lot of design firms are starting to embrace it too. And I think historic preservation is not quite there yet. I don't think they're embracing it yet. There is a little bit of momentum, but I think it's still a little early for historic preservation. And I think that's why we need to get this information out there. Why are these firms, or why are design firms, or why are contractors going to BIM? It's because there's a lot of different things about BIM that we're going to talk about, but it's the information inside of this model that you get out of BIM that really, really is valuable. And I'm going to start to talk a little bit about that as we move a little bit forward into the presentation. But like I said, two projects that I worked on. One was a state capitol building. The entire laser scan of the interior and exterior modeled at LOD 400. We will talk a little bit more about that later, but keep that term in mind. And then another big one was Hearst Castle, which is, if you haven't been there before, it's sort of like it used to be the mansion or a home, one of the homes, I think, for William Randolph Hearst. It's on the west coast, sort of in the central coast of California. And in that mansion or that property, there's a very large sort of castle, and there's these little homes or little side guest houses that kind of surround the main home. And we'll talk a little bit about one of those guest houses that I basically was in charge of creating from the ground up. So almost every single element on there was somehow I was probably involved in it. So we'll take a little bit of a look at that as well. So let's go into it. Building information modeling, or BIM. If you aren't familiar with this term, it's probably you're going to be familiar with it because everyone's talking about it in the industry. It's pretty much the new AutoCAD. So 25 years ago, when everyone was still hand drafting and AutoCAD came out, there was a little bit of a stir, and there was a little bit of a, not quite everyone was on board, but slowly, and now everyone's on board with AutoCAD. I think the same thing is happening with BIM. It came out maybe 15 years ago, and at first nobody knew what it was. People were a little bit afraid. They're already kind of set in their AutoCAD world, and they're happy. And then this thing came along, and nobody quite understood what it was because it was so different. Well, it's starting to catch up, and it's really, I think it's really valuable, and to know exactly what it is, so that you can assess whether or not that's something that may be valuable to your work or your industry. So this is what it is. It's a single virtual model, which means that it's basically a 3D geometrical model inside of your computer that can be shared and opened and by anyone. And really, one of the key things, a really cool benefit, is that it can be worked on simultaneously by many, like a limitless number of people. And you might wonder, how does that work? The technology-wise, I'm not quite sure either. It's pretty amazing that people can work simultaneously, but it's really nice because different trades can be working in the same model and see in real time all the little updates and changes that are being made, and also have a dialogue or a discussion amongst each other right then and there. This is going to save lots of time. It's just less rework, as you can imagine. As let's say you might be, if you are a designer and you're creating, let's say, a wall retrofit for, let's say, a historic building, and you decided maybe you wanted to make it thinner, but you may not have known that that was a load-bearing wall, let's say. And then the engineer who can see the file may look at the areas that need to be retrofitted, and is looking at this and saying, well, wait a second, this wall is not the right material, it's not the right thickness. I need to talk to, let's say, me, if I'm the designer, Joe, and say, hey, Joe, like I noticed, you were designing the retrofit, and I think that I know where you're going with this, because I know you like this aesthetic, or you think this is gonna stay in line with the preservation part of it, but we need to discuss maybe changing the material of this to make this work. So that kind of dialogue can happen immediately, instead of being like in the traditional process where a designer may complete a design, send it off to the engineer takes a look at it, may not agree with everything, send it back, and there's a lot of back and forth. Instead of that long time period, it can happen right away, and input from all the trades can be input right away. They can be worked on right away. So structural may not need to, let's say, wait for the designer to actually come up with the design. If the design is already progressing, the structural sub can actually look at that and say, oh, you know what, let's do this, let's try this. And it's really, that's probably one of the main things I really like about building information modeling, is that all the trades, plumbing, electrical, design, mechanical, structural, you name it, they all can work simultaneously. And because of programs like Revit, who have functionality built into each of the trades, there are special things that, like, let's say, structural calculations or environmental analysis can still be done on this model by different people. So if I was, let's say, I was one of the structural subs, I could start modeling my structural members and run the calcs right there inside of the program. So building information modeling is sort of, like I said, consolidating a lot of that information that used to be very, very kind of spread out or separate, and it's putting it all in one little thing. So it's really nice. Number 3 is the parametric ability. So what does that mean, parametric? It just means that there's rules that you can assign to all kinds of things, like elements. So for example, an easy one is, let's say, a door. Especially if you're working with a historic building, you might have doors that were, built a long time ago. Maybe they're very, very thin, and because of that, they don't actually work with any of the laws, the current laws of like ADA requirements of a certain width that needs to happen. Or in another one would be ramps. Maybe there aren't any ramps, but you have to build a ramp now because of ADA requirements. The parametric ability allows you to assign those rules, those sort of minimum requirements, in a simplistic term. And this is just one of many examples, but you could assign a rule to the geometry that you're creating. So let's say, for instance, the door width needs to be at a minimum of 3 foot 6 inches wide. If that's the case, you can actually assign a door type to always at least have that minimum, no matter what size you're creating. Or for example, a ramp that needs to have a certain rise over run and a certain slope. Well, you can create a rule so that basically you can start sketching out the ramp that you want, but it will always, no matter what you're trying to do, stay at that slope. So the parametric ability is really nice. It's also really well used by designers. And so you'll see, you don't see it as much as in historic preservation, but I can imagine that it could still be used in terms of, let's say, interesting facades that have more and more of like a mathematical quality to it. So you'll see apertures of openings sort of nicely, organically sort of get smaller or larger. I would see something like this in my mind happening probably like in a museum or something, where you're mixing old with new, and maybe there's an addition to a very historic building, but the designer wants to put a contemporary twist to it. Well, these parameters will allow the designer to really come up with a lot of different iterations of a design very quickly. And because you're in Revit, you're in a single virtual model, you can start to see how that articulates with the existing fabric. And does that look well? Does that work? And again, like because everyone can work on it simultaneously, even the client can be in the model. You don't necessarily have to, wait or have to, basically wait on the designer to come up with something and have him basically show you a couple screenshots. You as the client could go in and look at the model and have a discussion right then and there with the designer. And in my opinion, that kind of information, to be informed that early in the process, is going to lead to a better result. So another really nice thing about building information modeling. And lastly, it's simply database driven or database based. What does that mean? A database is basically a storehouse for all sorts of data. So a door has, let's say, a width, a height. It might have a certain detail on it. All of that stuff is data. But also what could be data is the manufacturer, where you purchased it, the website, contact info, fire rating, all of this stuff, material, color, all of this stuff in essence is data. And what I like about building information modeling and why I think it's pertinent to historic preservation is that all of this data is actually useful to historic preservationists. They're the ones actually that really care about a lot of this stuff in terms of material, color, maybe like even if there's a certain stone facade, and the way that even the stones are arranged, I've seen where historic preservationists really care about that kind of stuff. And if that wall needed to be teared down temporarily to fix something behind the wall, they still want to have the stones, let's say, placed in the same way that it was placed before. And that could have been done traditionally via photographs, and this is a very simple example, but it can also be done with a virtual model. And I think it's going to be more interesting with a virtual model because the virtual model you can get measurements off of, and it can be very precise. And I think that's going to be better solution than let's say a photograph of just the stone wall, let's say. So just know that BIM modeling or BIM is database driven. Everything that you're seeing on the screen has all this information, and actually infinite number of information that can be associated with it. And that's all stored in what they call a database or just a file. And Revit or BIM is looking at that and getting the information from that. So that's what I mean when I say it's database based. So what is BIM, or the I in BIM, which equals information? It really is about information. So this little diagram, it's really perfect. Even though it's very simple, it really tells you what you're getting. You're getting a 3D model, so you're getting this three-dimensional, let me get the pointer here. So you're getting this three-dimensional model, which is great. It's good for visualization. It really helps anyone understand what this project looks like, feels like, maybe even what it's like to inhabit that space. Really easy to visualize. but also you're getting these kinds of drawings that you need. Typically elevations, sections, detailed drawings over here you're seeing, plans. You're getting all that, those sort of construction documents that anyone would need in terms of to document the building, or if you need to retrofit the building or uh, remodel a space. All of this stuff is necessary, but because you have this model, any of these drawings can be pulled out instantaneously, and it can be updated instantaneously as well. So if a wall gets, let's say because of a remodeling of an office space, we needed to remove a wall, that wall can be removed in the model and it will update in all the plans immediately. Whereas in the past, let's say in AutoCAD, a wall would be, let's say, decided to be removed, it would have to, if you had a 3D model, it would have to be deleted in there. Then if you had an AutoCAD 2D drawings, it would have to be deleted from there. And if you had certain sections that had, that wall there, you would have to delete it. And it would be a very manual process. And, as you can see, with that many steps involved, errors are bound to happen. Someone's going to forget something, and it's just not going to be as accurate. If you have it all in one model, it's as simple as deleting that wall from that model, and it just disappears in all the other drawings. So really, really essential and really, really awesome. I'm going to talk a little bit more about a feature called phasing as well that is implemented in BIM, and phasing allows you to sort of almost, you can use it for future or historical purposes, but in this case, you could use it as a historical kind of a archive purpose, where you could say, this was before we actually did the retrofit, and it will show you the actual building with the wall. But then you could say phase, a future phase where this is the building now at its current stage without the wall. So really, really awesome, and all of that stuff can be kept in track of as a history, so it will never sort of go away. Whereas in the past, you might have to, the only way you would have to do this would be, you would have to create two models, basically one of the old version and one of the new version. So you can see that having all this information in one model is really, really nice. Along with that is over here, you can also create schedules. Again, this comes from the database. So if let's say a simple one that everyone uses in the industry is cost scheduling, right? So if you know the cost of a certain type of door that you're going to be installing in the building, or even a window, let's say, you can associate a cost with it, and it will automatically know, because it's database based, it will know how many of those particular walls, or I'm sorry, doors or windows are in the building, and just add it up. So that's really, really powerful. And in more powerful, more sort of interesting ways I've seen used is, let's say, for instance, you're doing glass windows, and your fabricator is telling you that, hey, I can make this glass, but really the cost, what's driving the cost is the square footage of glass that you need. So they'll give you a price. They'll say, X amount of dollars per square foot of glass. And so, okay, well, you can actually have, because it's all database driven and data driven, you can do multiple different designs or styles of windows and see your schedule just update automatically, and it'll tell you the exact square footage of glass. So maybe instead of a thinner mullion, you might want to do a thicker wooden split piece, and that cuts away maybe 20% of your square footage of glass per window. You're going to see instantaneously what that entails in terms of the cost percentage and how much you've saved. So there's a lot of really cool tools that can come out of building information modeling, and I'm still not finished, which is you can also create exports, so it can export it to other fabricators. Let's say if you need to fabricate something in terms of 3D printing, or there's all kinds of ways to do it now. And lastly, even video sort of fly-throughs or demos that you might want to show potentially interested investors or clients. All of this stuff just happens in one model. So really, really powerful, really awesome that you can do that with one thing. So this is a screenshot of Revit itself. So this is a BIM program. This is actually what's going on, or what I would see is when I'm modeling, let's say, and you can see all the varied windows that I can have open. I can have more open than this, but take a look. You've got your visualization here already kind of showing me in real time what maybe the building will look like. You've got here a section detail of a wall that I've detailed out, plan here, another aerial shot visualization that can be rendered out as an image, and then here's a simple schedule. So all of this stuff is coming straight out of the model and without much extra effort. Pretty amazing. See another example here, which is a wall. So typically in other modeling programs, a wall that has layers like this wouldn't necessarily be built this way unless it was intended to. Typically, you would just create a rectangle that's extruded, right? And it would be up to the details or something to tell you that there are actually layers in this wall, as most walls are. You've got your exterior, in this case, brick facade. You've got an airspace here, and then you've got some insulation. And this one has CMU block, and then it looks like the drywall on the interior. So, that's real life. And real life, that's what a wall looks like. But in typical 3D modeling, you don't do that actually, and that's kind of inaccurate. Whereas BIM allows you to create walls that have layers just like they do in real life, with the associated thicknesses, with their associated insulative capacities or fire ratings, whatever. All of that information can be put in. So this is a great example of, let's say, this wall here and all of the information that has been put in. And this is just what's been put in for this wall. If I needed to put more information in, let's say there wasn't a category here that really I needed to put in there, it's not an issue. You can always put one in. So that's sort of the flexibility. And look at this, it's got the help file, so the website to go to for this, the date it was issued, sort of the materials, thermal resistance capacity, the manufacturer's URL, global warming potential, green rating, green guide rating. So there is just so much information that can be put into this that would never be able to really be communicated in a typical 3D model. And that's really the value of BIM here. And you can imagine, as a preservationist, how useful this will be, especially if you're no longer there. If, let's say, if I was a preservationist and I was in charge of some historic building, and 50 years from now, I'm not alive anymore. I'm gone, and something happens to the building, and they need to actually repair or replace let's say, a portion of a wall, and people can do it, I think, the traditional way, which is sort of examine the material, try to make their best guess, and maybe experiment with a couple or two suppliers and see if someone can get it to look right. Or if you have a BIM model, just open this up and click on that wall, and you'll see all that information that was originally input in there. So I can be like, oh, well, actually what we need to do is we need to contact this manufacturer and see if they still manufacture it, or if they know, if they're not around, or if they know something equivalent. Like, all this information is now right at your fingertips, and I think that's really where the value is. I think when I worked on one of the projects, the Hearst Castle project, one of the main issues and the reason why the client wanted to do a BIM model was that all the documentation that was existing for that was pretty much all, because it was hand drawn on like paper or mylar, it was pretty much illegible at the time. Either the paper had rotted away, or the ink or the pencils were so faint that you would not be able to get any useful information from it. So in terms of any sort of restoration, or any sort of, let's say if some kind of disaster happened, if something needed to be recreated, there really wasn't a good reference to document or figure out like how are we going to repair or how are we going to fix something that we may need to in the future. And that's really where I think BIM came in for them, and they said, okay, I think this is going to be valuable. And from my experience, it seems like it's very, very valuable, because not only are you getting this information, this sort of, maybe I would say to some people it might be more boring information, but you're also getting the 3D geometry and a lot of examples out on the web, or even if you go to any other webinars, they're going to show you buildings that are very simple. You're going to see a lot of boxy, sort of orthogonal buildings that don't have a lot of complexity or detail to them. Whereas, and you're probably thinking like historic preservation, we're dealing with much more complex shapes, right? Very organic. You just think about a column capital, like a Corinthian capital. Um, you, you know, you don't see that, and it makes it seem like you don't even see that actually in regular modeling, and it makes it seem like you know, maybe this isn't going to be a good fit. But I'm gonna show you that actually it can be done. That was basically my expertise, was to figure out how do we create sort of these organic shapes or even statues or faces or very things that are actually very, very difficult to do. How do we do that in BIM, and can we do it in BIM? And so I'm going to show you a little bit about that it is possible, and there may be some value in doing that. So this is a little what they call Wordle, or a diagram of basically what people are really searching for when they're searching for the topic of BIM. And so the larger the font is, the more often searched for term in the whole category of BIM. And what I'd like you to notice in this diagram is that it's not building information modeling that is the largest or most often seen of the search terms. It's actually this little search term here, level of development, or LOD, and then there's these numbers associated with it. So you see 100, 200, 300, 400, and 500. And this is a really, really important term that we need to understand if we want to do BIM. And this diagram, I think, hopefully hits it home that most people actually don't have a good understanding of what this is, even though it's in some ways the most important thing about BIM. So let's go into it, and let's take a look at what is level of detail. Some people also call it level of development. So I think it can be used interchangeably. Again, this terminology is sort of there are going to be sides where some people will say no, they're totally different things. Some people will say they are the same. In my experience, I feel like they're the same, but you may hear different opinions on this, and I think this comes because it's still relatively new. BIM is still kind of the new frontier. Still, it's not mature yet in terms of adoption. I don't think everyone's on board. It's getting there, and I think there is a drive to get to BIM, but because we're still in that early stage, these standards still haven't been set in stone. But simplistically, at least for me, and I haven't had any issues with this, is level of detail and development are pretty much the same thing. So let's take a look at this. This is a little piece of a classical part of the state capitol building that I talked about earlier that I was working on. And so this is just typical. You probably see this in most any capitol building or government building. Is you might have to correct me on the terminology here because it's been a while for me, but you know, the cornice, I think, is what they call this. And you know, this area here with the column capitals and the column stem, and this is the wall that separates the exterior and the interior, and then you've got your floor slabs. So as you can see, as the numbers increase, the detail level is really getting more and more detailed, right? So over here on LOD 100, you're seeing what looks like almost like children's play blocks, right? Just little basic geometric shapes just stacked on top of each other or just kind of put next to each other, and that's basically it. There is no detail in terms of does this have a cut or a hole in it, or nobody knows. It's just solid geometry. LOD 200 gets a little bit better than that. I mean, you're starting to see a little bit more information where, oh yeah, there's actually a cut out of this triangular wedge piece here. Oh, actually, the columns do start to get thicker at the top here, making it possibly a capital. We're not sure, and we're not even sure if that's what type of capital that is. It's still very ambiguous, but it's giving us a little bit more information. LOD 300 really starts to hit it home, right? So you're starting to see a lot more detail. You're definitely noticing that this definitely has to be a column capital. You're seeing little little trims here. I can't remember what they call these little, maybe dentals, I can't remember, but the little pieces that hide underneath the edges of the cornice here. And so you're really starting to see some articulation. You're even starting to see that the roof has a little bit of a slope here to get the rainwater to come out and down. So a little bit more information. And this is typically a very well used LOD. And then it goes to LOD 400, which is more of like almost like a fabrication level, where you're seeing, aha, these are actually Corinthian capitals. I'm starting to see the fluting and the little leaves, and you're really starting to get really accurate. I mean, you're starting to even see layers in the wall. So you're seeing the exterior wall layer, interior wall, probably the structure of it, and then the interior wall. So very detailed, almost to a fabrication level. This is actually going to tell you a great deal of information about the building. So this is kind of the range that GBG, or the geotechnical company that I worked for, used, but I've seen this, again, this is not standardized yet. I've seen it go up to 500 or 600 as well. And really the only reason to subdivide it is that somebody in their mind has a more subtle version that seems to fit better between these numbers. Instead of having 4 categories, you know, some people like to have a little bit more because they have a certain subtlety to it that is more relevant to them. It's similar to, like, you know, just as an example, you know, like movie reviews. You know, some people just do the thumbs up, thumbs down, and that's only 2. Some people do 4 stars out of 4, like the 3 out of 4, 4 out of 4. Some do 5, some do out of 10. So it's kind of the same thing. It's just giving you a little bit more of a category in between if you need it. And some people even go to, instead of doing 600, they'll do like 100, 150, 200, 250, you know, etc. It's all the same thing. But for our purposes, we're going to stick to 100 to 400, and yeah. So here we go. And now we were looking at a more kind of detailed area of the building, but let's take a look at what does this mean for like a building scale. And this is LOD 100 at the building scale. And notice it's really only good for what I would say conceptual massing, or maybe some analysis studies. So like, let's say a temperature or environmental studies would probably be good for this level of detail. If that's all you're interested in doing, you probably only need to use LOD 100. But as you can see, it is very abstract. You can't even tell how many stories or the heights of these buildings are. Everything's very blocky. So you have really no idea what this really represents. But then you go to LOD 200 and things start to get a little bit clearer. So now you're seeing that, you know, this building, actually, that little rectangular thing wasn't rectangular. It's actually a kind of a circular dome. There's actually a little bit of you know, slope to the roof. You've got, looks like 3 stories here. But again, it's still relatively simple, and it's not accurate. It's more of a representation of what's there, but you're not going to be taking exact measurements from something like this. Same goes here. This house, you're starting to see slopes on the roof. you're starting to see you know, a little bit more articulation, but you're not quite sure what this is. Is this just a kind of a porch here platform with a sloped side that you can't walk on, or can you walk on that? You're not really sure. It's very vague, and it's done this way because this is you know, level of detail 200. Now, I've never used level of detail 200, and I've never seen it used actually, even though all the literature in BIM talks about it. So I'm not quite sure what real use this is or what value this is, but I'm guessing it's for visualization purposes. So if you want to do these sort of conceptual massing studies, but you still want it to see or seem like it looks like what's actually there, you're going to use LOD 200, because if you're let's say for instance you're showing this to a client, this is probably not going to be that interesting, and they're probably going to maybe even worry a little bit that, is this really accurate? This doesn't even look like what, you know, my building. Whereas if you do the analysis studies, which you can still do on these models, and they look more towards what's actually there, client might feel a little bit better, more confident in the results. So that may be, and that's just my guess, is that may be why LOD 200 exists. Again, I've never seen it used. LOD 400 now keep in mind, we're looking at the same exact buildings. So this building on the left here and the right will continue to be on the left and the right. So see, that's the same building on the left and the right. Here we are at LOD 400, which I call the fabrication level. And now you're starting to see exactly, this is almost like a photorealistic representation of what is there. It's the fabrication level. A contractor can look at this, go through the model, take measurements from this, and literally know exactly what to put, you know, where. So for instance, this state capitol building, you know, let's say this window, this little rectangular window here, needs to be replaced. Contractor can take this model, open it up, take measurements from it, figure out, you know, where the mullions were originally, and either, you know, now it's going to be a decision up to the preservationists or the designers to say, do we want to, you know, replace it with something that was exactly the same as the one there? In this case, if it's just a one-off instance, probably. But if we're retrofitting the entire building and we're taking all the windows out, you know, that may be an opportunity for the designer and the preservationists to look at, you know, this model and try a bunch of different versions of different types of windows. And you might think that that's what's the interesting thing about that, but it can be, because designers might care about mullion placement or sizing of glass and how that changes the facade. And, you know, some people might say, you know, does that add to this building or does that take away? And, you know, that's the whole point of this, having this model, is you can do that instantaneously. And the nice thing about BIM, as I said before, is that a lot of this stuff updates instantaneously. And so if you, let's say, had this window, and I know in this case this window repeats multiple times in this building, so you see it here, you see it here, and then you see it's mirrored on the same side here and here, but it's also mirrored on the other side of this building. So you're seeing there's 8 instances of this same window. Well, as a designer, I could actually go in, create a new window that fits that exact same profile, and just swap them out, and it'll take literally seconds, and it'll swap out all 8 of them at every time I try, you know, every time I want to swap it out. And you can instantaneously get an idea of whether or not this is going to be a good fit or not. And so another really nice feature about BIM that just doesn't exist in any other 3D modeling software. Other 3D modeling programs, and I know this very well because that's all I used to do, is if I had to do that, either this thing would need to be a block and I'd have to create a block and do it that way, or, you know, I would have to literally go in one by one and start swapping them out. And again, the more steps that you need to take, the more chance of error. Whereas BIM, it really starts to reduce a little bit of that. Again, look at this one. This is the guest house. I was talking about at Hearst Castle, LOD 400, you're really starting to see a huge difference. So that wedge-shaped thing, you actually can walk on it, and it's not a slope, it's actually a staircase. And you're starting to see, all of the different balusters, the fountains, and even the material of the the buildings are integrated into this. So when I created these models, we were going off of either site visits or what we know, or photographs of the actual material, and trying to create materials that not only look like what's there, but also has the same information. So if I know that it's stucco, then I'm going to go ahead and create it as stucco, give it that identification, so that in the future, if somebody ever needs to, let's say, God forbid, but let's say the whole thing went away from some kind of earthquake or something, then they would know. If they had the virtual model, they would know exactly what material was used, what the color was, etc. So that's really where I start to see the value of BIM. So that's LOD 400. And again, like I said, fabrication level, let's say for instance like these statues, or even a simpler one, these sort of balusters down here. LOD 400 is taking into account not only the geometry, but also placement. And I've never seen this in any other type of historic preservation work where I see it done with a 2D version of like an elevation, let's say. Usually these balusters, and this may or may not be important to you, but I think it's important to me as if I was a preservationist, was that you'll see it in drawings where the spacing of these balusters are just pretty much generalized. So they'll take a measurement on center, let's say it's 6 inches on center, and they'll just put them every 6 inches all across the drawing. Well, in this instance, we were doing it at such a high level of detail that I basically was taking the laser scan data information and placing these. And as I was placing them, I realized that maybe because it was hand built back in the day, that none of these balusters are actually exactly a certain distance away from each other. So I would see instances where they're 6 inches apart off center, or I've seen them 5 inches, 4.5 inches, 7.5, and it just varies slightly, and you don't notice it when you're there or you're looking at it from this distance. But if you go carefully and really look at it, you'll start to notice that they aren't actually equidistant, and I think that's valuable and something that we should know, and it is useful in preservation. And that's another benefit I think that you can get out of BIM, is that it can be modeled to a very high degree of accuracy. Not only that, geometry can be too. So, let's say one of these statues for some reason was damaged. Well, the level of detail that this model was at, you're getting features that are pretty much like a sculpture. So museum quality sculpture. So you're getting very high level of detail where you're seeing the almost softness of a hard material really there. And what the beauty of that is that you can take that to a fabrication type of environment, and basically there's many different ways, but you could 3D print it, you could create a mold from it, and then use that mold to whatever material you want to cast it in, recast it. And I talked about this with John the other day, is that not only that is, let's say if you want to really preserve that quality, that hand artisan quality, let's say, because some people might say, hey, it's 3D printed, or it's just a cast mold now, it's not pure, or it's not like the original. And I've seen, and I'm sure you guys know more about this than I do, but I've seen at expos where there are firms or companies that basically take photographs of, let's say, details, or in this instance, a statue, and they will take a block of stone and have an artist or an artisan literally start to chisel away at it, but they're only looking at multiple photographs to use as their reference. Well, how much awesomer or how much better would it be if you had like a 3D printed version that was super accurate of what was originally there for the artisan to look at and reference that to chisel away at whatever piece of stone that they're working on. I think that that's going to give you a much better result and more accurate for what was there. So really, really exciting stuff, and you're going to see in the case studies later on how detailed you can get. And I can tell you it can get very detailed. With the laser scanner that we used, I think they market it as like 2 to 3 millimeters of accuracy. I would say more realistically, it's probably 6 to 8 millimeters of accuracy, but that is still a very, very high level of accuracy. 8 millimeters is nothing. And really, if you can get that kind of accuracy into a model that's to scale, that represents exactly what was there, that's really valuable. And much more than photographs or somebody sketching or somebody just using a tape measure and just getting some dimensions and saying, I'm done for the day. So that's really where I think BIM and historic preservation have some sort of relation. And I think historic preservation really should start thinking about using BIM because you can have all these features there all in one model. So relevance to historic preservation. So I may have gone over some of this, but let's say here, obviously it does communicate the form, which is very important to historic preservation. And as I said before, you can set up phasing where you can see different stages of the building and how it progressed in the past history of it, or even future things that may happen to it. If you have a plan to renovate certain areas of it, you can also show that in phases and see how that potentially changes the fabric and what does that look like. That's really, I think, valuable. Again, it includes data to identify and inventorize. So I touched on this before. You can identify all of the different elements inside of the BIM model, as we saw. Let's see, where was it? As we saw here. So you can identify everything, but you can also inventorize, which I think I didn't say this term, but what basically by talking about the schedules, I think I implied it, which was it's keeping track of how many windows of a certain type you have in the building. It's keeping track of how many doors or how many types of walls or square footages. It's inventorizing that so that you can pull that up and create a schedule from it at any time. So really, really nice. Again, ability to phase and represent multiple points in history or the transformation of the building. And you can also record demolition effects and how does that affect the building as well, because a lot of times with rehabilitation, some things need to be demolished in order to be added onto. And you can see that prior to actually doing it, which I think is pretty valuable. You might, in the past, have just taken someone's word for it, or someone might have sort of explained it. But I think to see it in 3D is really powerful. And you're going to see, oh, we demolished that area. What does that look like? And when we add the addition we want to do, what does that look like before we even get started on it? So really, really amazing stuff that would be actually more difficult and more work to do via other methods such as traditional 3D modeling. And so at this point, I think a lot of people do ask a lot of questions about, these two main ones right here is, and I'll just read them to you. To what extent will the existing conditions be investigated and modeled to enable the desired visualization and documentation? And to what extent should existing conditions be modeled in order to communicate how they should be preserved or modified? And really, this is kind of the same question, and the answer is level of detail. It's really all about that, and how BIM is going to be able to, with the many aspects that it can do, you're going to start to choose and figure out what areas of BIM you're going to use to either do your visualization or your documentation, or figure out which areas need to be preserved or modified. So, BIM can do basically what they call 3D to 7D. All the numbers it's just another aspect of the modeling. So, you know, we all know like 2D and 3D, there's a huge difference. But then once you get past that, it's more of an interpretation. But this is sort of the industry standard. So 3D, obviously existing conditions modeling, animations, renderings, walkthroughs, visualizations, right? Then you go into 4D, which adds the element of time. So we're talking about scheduling. So you're starting to start doing phasing. You're starting to create those simulations. Phase 1 from, let's say, July to September. How much of this project are we going to plan to get finished? You're going to see what that looks like. Can we inhabit the space afterwards, or figure out ways to inhabit it while we're doing construction? All this stuff starts to fall into 4D scheduling. Really important, and that you can do that in BIM. That's really amazing. Let's see here. We got a question real quick from Dorothy. Would it be very expensive to collect all the data for BIM to work? I think that's the preservationists would know better than I, but I don't think it would be much more expensive than the way I've seen it done so far. So, usually a contractor or subcontractor gets hired out to either somehow document the building, right? So whether it be in the past with measuring things, or photographs, or somebody doing that and then taking it into 2D CAD to create drawings. I don't think that time would be necessarily more expensive to do in BIM. That data collection is probably going to be about the same amount of time. But again, this goes down to level of detail, which we're going to talk a little bit about I think further on, but I can talk a little bit about it right now, which is it's really, really important to figure out what level of detail you need and make sure that that's the right level of detail for your purposes, because it would get very expensive to, let's say, do the LOD 400, what I said, fabrication level, especially if you know for sure that maybe that area or this building doesn't really have that risk or danger, or that's not really concerned to preserve, the exact look of every statue in the garden or something like that. If that's not the case, then definitely LOD 400 would not be necessary. And I think as a consultant, I would never advise to do that. But if you're like, for instance, Hearst Castle's case, a lot of that stuff was collected, I think, from Europe or somewhere, and they're like all one-off museum pieces, pretty much works of art. These are things that if they were destroyed for some reason, there would be no reference. There would be nowhere to go to get another version of it or something. It would just be impossible. So they wanted to have that documentation, just in case, I think, and that makes sense, because they're thinking about their estate as almost like a museum. When it's more of like, let's say, the state capitol building, that may not be the case, and you're going to see instances where LOD doesn't necessarily mean for the whole project. So I simplistically simplified it in those diagrams to just say, yes, this is LOD 400, this is LOD 200, but the same building can actually have LOD 200 and LOD 400 in the same building. And to give you an idea what that means is, let's say, for instance, like that state capitol building, you might have these very permanent public spaces, right, that are maybe where the vertical circulation is. Those areas actually typically don't change very much. They're going to stay the same year after year, decade after decade. Nothing is really going to change. And if everything's sound in terms of the structure and everything, and there's no issue, what I would say as a consultant would be, you know what, this area, if we want to model it, we'll model it at a level of detail 200, and just keep it simple, just to give an idea of what's there. But let's say there's offices in that building, right? So there's All the other little tiny adjacent spaces are offices, and typically offices actually have more work, more change that happens to them throughout the lifetime of the building. So in that instance, maybe we want to document that very carefully. And how do we do that? We're going to actually go to level detail 400 in that case, because we really want to see and know and document what was there and what has changed over the years, and maybe certain walls or wall details get put in, left out. That's really where it would be the case. And I know we only saw the exterior of Hearst Castle, and there's actually a reason for that. The exterior was the what was supposed to be at LOD 400. The interior of that little guest house was supposed to be, I think, a LOD 200. So you're not, if you go inside the model in that interior of that building, it's pretty much bare. There are no furniture, there's nothing. So all of the little ornate things that are on the inside of these houses actually is not documented. And that's what they decided on, and that's what they thought was best for their needs. So it can always be different. So just know that, and again, I don't think it would be that much more expensive, but I will say that LOD 400 would be expensive. That is very, very time consuming. And so we got another question. How about level of data for disaster recovery? So disaster recovery, yes. If you are, and I think that's where Hearst Castle kind of, what their line of thinking was, if there was a huge disaster in California, the main problem or threat is earthquakes. What are we going to do in that case? And I think that's where they thought, what, we really, really need to have something where it's fabrication level, where in the instance where disaster struck and there was pretty much everything was obliterated, then can we rebuild? Do we have enough data to rebuild? And then in that case, yeah, level of detail 400 is going to be what you need. And it's probably going to be dependent if they chose to do only the exterior, and it might have been a budget thing. I don't know, because I wasn't part of that whole negotiation process, but it may have been a budget thing. I'll tell you, LOD 400 is very time consuming, and I can imagine it's very expensive. But yeah, you would need more data for disaster recovery, for definitely. And hopefully that answers your question. If not, feel free to ask me again at Q&A, and we'll continue onward. So BIM 3D to 7D. So we were at 4D, the phasing, and then also we've gone to 5D. So again, costs at this point. So you can put in or associate all sorts of costs to anything, really, structural steel, amount of MEP, or piping or plumbing or mechanical ventilation you got to put in. The examples I gave was square footage of glass. All of that stuff can be put in and associated with all of the elements in the model, so that you can quickly get cost estimates and see that update in real time as each element may get modified or switched out with something else. Sustainability, there's a way for you to basically do energy analysis and studies. But this is important if you really care about that LEED or want to get LEED for a historic building. You can do it in BIM, and that's amazing value. I think that's a really, really cool thing. That I think Microdesk also, their LA office is in a historic building in downtown LA, and it's a LEED rated, and I don't think it was LEED rated 20 years ago, and I think they made a lot of modifications, and I'm sure if they use BIM, they're probably using some sort of an energy analysis to figure out how or what things we need to maybe renovate or change or update to get that LEED rating. So that's awesome. Finally, 7D. This is probably the most important thing for preservationists, is thinking about the future of this building, right? Basically, after I'm gone, or after people in charge of this project are gone, can the maintenance and can all that information still be accessible? And I'll tell you, with BIM, yes. and it's getting so much better now with the iPads and the sort of mobile devices that now it's pretty much like if you can open up these Revit models on tablets, and basically if you're out in the field and you're staring at a wall, and you're like, all right, so this wall needs to get demolished, but I don't really know what this wall is made out of. You can literally tap on the wall in the model and get that information that we saw in that previous slide, and it'll tell me, oh, okay, so this is the manufacturer, this is the fire rating, this is blah blah blah. All of that information is there, and how awesome is that? And the fact that you can have that on a mobile device and literally be looking at the same thing that you're looking at in real life. So that's really, I think, the ultimate benefit of BIM is this facilities management application, or this sort of 7D future archive, or it's a document that basically will live with the building. As long as the building's around, this document is going to be a very helpful, useful device to be with the building, and it can always be updated as the building gets updated too. So those are the sort of different categories or dimensions, I guess, of BIM, and you will, as you each different project, as you are working on them, whatever the needs are, you're going to start to figure out which like D's you're going to need. So it might be a combination. You might be I need 3D and I need 7D, or you might need all of them. So this is just something good to know, that BIM has the capability to do all of these things. All right, so we're going to go into a deeper dive on the sort of main categories of BIM, and each of them really, hopefully this will give you, I've sort of made this so that hopefully this encompasses pretty much the main meat and potatoes of BIM. Obviously, BIM is very deep, and there's probably a lot of other things that if some of you have experience in it, you might be like, well, why didn't he talk about this? Well, I think that these categories that I talk about are the main guts of it, and I think it's really important for at least people who are new to it to know about them. So let's talk about them. First of all, it's data. And regardless of whether it's a historic preservation project, or whether it's a new design, new build, there's tons of data that we as designers or preservationists have to manage, right? And that can include, as we've already talked about, door types, door manufacturer, or window manufacturer, or the list can go on and on and on. Type of concrete, this thickness of rebar, whatever it is. All of that stuff is data, but there's always a challenge on how to manage that data. Well, in the past, it was very sort of separate, right? Especially with between trades. Structure kind of does their own thing. The plumbing contractor does their own thing. They kind of work with the design, but it's still very separate. And as the designer, you don't have as much information or input. There's no dialogue between you and the plumber as much. And that data is always sort of separate. Well, now with BIM, all of it's put together, and you can have a much more informed design, and hopefully because it's more informed, it's going to be better. That's not to say it always is. Again, BIM requires a lot more communication, but if the communication is there, the management of data, because it's all in one kind of consolidated model, it's going to be much easier, and hopefully a much better outcome too. And so another thing is that we talked a lot about this already. The model can associate data with elements, as you saw. Walls can have fire ratings and etc. And it can be continually updated and modified. So if that wall changes, or for some reason, let's say a new study decided that the fire rating is actually a little bit different, all of that stuff can be updated immediately, and it will populate throughout the model. So let's say if you know that the wall that's the exterior wall that's being used for the entire envelope is actually a different type of, I don't know, let's say concrete than was actually there, you can just update the numbers and boom, like the whole entire thing that used that element will be updated. So pretty nice feature. And again, model can be queried for embedded data to derive schedules and customize view. So at any time in BIM, you can always make a sort of schedule or a spreadsheet from this embedded data. You can say, you know, how many rooms have this fire rating, or how many walls, or, you know, what's the total cost of all, you know, all of this material. So really, really awesome. And I'm going to show you a little example of what I mean, which is, if you take a look at this example, this is 6 screenshots of the same exact floor plan, but it's represented differently. And it's just using the data that we saw earlier, and it's just querying it. So, you know, here's the department. There was a category for department, and each room was given a department. So then you can give it a color, and boom, like your plan just immediately updates, and you can quickly see that these 3 are marketing. It's awesome. And then you can go to here and see, oh, which areas have open spaces, and it looks like only maybe half of this room does. By brand, by name, by type of space, area type, and this is infinite. It's only showing here because the input data category was type of space. I could have called that, you know, type of, anything, type of room. It doesn't matter what this is, as long as you give it some sort of parameter here, then it's going to look for that, and it's going to always associate itself with that. So you can see that this is visually powerful, but you can also do it with more of a kind of a Excel spreadsheet look for more of a numerical output or things like that. So really, really awesome that you can just do this all within one program. This would take lots and lots of headache and heartache to do this, I think, the traditional way, with AutoCAD and just having to manually kind of create all this stuff. Second category is geometry. So in the past, different compositions of views were created, but they're sort of independent of each other, right? So someone might create a hand rendering or something, but it's just this independent thing that doesn't really, update. Let's say if the facade changed, well, that person now, their rendering is pretty much irrelevant because now they have to make a new one because the design has changed. Well, not necessarily with BIM. Everything is connected, and because of that, things will update. Your visualization updates, everything updates, and you can phase it so that if you can go back to the older version if you wanted to. So again, in BIM, all of the elements, they are not separate and independent. They're all interrelated, and that includes doors, windows, anything is interrelated, and you don't see that necessarily in any other software. Again, different LODs for different purposes, can coexist. We already talked a little bit about this, but again, it's just going to depend on the purpose of what you need for that area, and an LOD can be assigned. And because it's so maybe complex in this way, where different areas of the building can have different levels of detail, there definitely is a need for what I would call the BIM execution plan. You're going to see this terminology thrown around a lot. And what this is it's just a document, almost like a manual, that kind of lives with the project. And what it does is it really outlines specifically what areas are leveled to what level. So I'm going to give you a quick example here of a BIM execution plan, and take a look here. This one goes from LOD 100 to 600, and it just tells you which components, site utilities, hardscaping, landscaping, here in structure, foundation, precast, and depending on what stage, and this is a new construction one, but depending on what stage, it's assigned different LODs. And this just keeps everyone in line. It keeps the modelers in line, keeps the clients in line. Everybody understands that, oh, I'm only expecting to see LOD 100 for the hardscaping when we're at CD level. And this is really, really useful. And they come up with these numbers, again, just by assessing the needs. And you can imagine hardscaping was like sidewalks and stuff. You don't necessarily need to have that at a high level of detail for construction documents, and it makes sense. So, but you can see as built 300. So, obviously you're starting to see maybe more of the articulation of the sidewalk or the divisions in each of the panels of the sidewalks or whatever it is. So this is typical piece of a BIM execution plan. It's much more involved. It actually, if you look it up, you're going to see who models what and all kinds of stuff. But it's really a document that everybody who ever touches this BIM model should be familiar with, like a manual for instruction manual for any product. Another category is layers. So again, different from other modeling softwares is BIM allows you to create assemblies with layers in them. A good example was that wall we saw earlier with the brick facade. Again, typically in a modeling software, that would just be an extruded rectangle with no layers in it, and if needed, a modeler would have to create multiple rectangles, and it wouldn't actually look very clean, especially in those kinds of modeling softwares. But in Revit, it's not a problem. It understands that walls have layers and are built-in layers and can have different materials, different thicknesses, different designs, and it allows you to create those. And how awesome is that? Especially if you want to be accurate, especially if you want to be more of a preservationist. That's really good information, not only for the preservationists, but for the people who are actually building this stuff or doing the renovations. It's very clear in terms of what needs to be done. An example of a wall assembly in Revit shows you right there. It's another different example, but again, very, very clear on terms of what materials go where, how high, what thickness, the scale, everything. It's there. And how useful would that be to a contractor instead of a 2D drawing? I think this would be much more powerful, much faster in terms of to just communicate with them. Okay, so the next category is form. Interestingly enough, even though, again, a lot of the examples you're probably going to see in BIM are very rectilinear, kind of boring, simple shapes. I'm going to tell you from my own experience that it's good at doing that, but it can still do the very complex, and so complex that more traditional modeling programs will actually probably crash, but I noticed Revit doesn't, which is pretty amazing. But complex geometry, again, with parametric modeling, you can also do these mathematical patternings that I was talking about, and so pretty interesting to use that, let's say, to maybe update certain areas of the building. You kind of see this a lot with architects. They do it. I think if you guys are familiar with like the design field, like Herzog Demeron have some kind of museum that they renovated in Italy, I think, and it uses the existing sort of building, and they've done some interesting things to it. And BIM would be the perfect tool to do that. And these parametric tools could also be potentially used for that. So really awesome. Again, these tools, not only do they help you create crazy form, but they also help you inform your choices about, what can be constructed, and, take a look at it in 3D and move around it and create visualizations, and you can see whether or not it really blends in well or really, actually helps the design of the original design of the building or not. So I think that's super important for especially historic preservation. Be awesome. Sequencing, again, you can phase all of the data and enable like basically the visualization of different stages of the building. So whether it be past or present or future, you can always create those phases, and that's really valuable. And it's not only valuable for historic, but it's also valuable for future, because if you know that this is a multi-year long project that it's going to take, let's say 4 years to do, it'd be nice to see, by year one, or 6 months from now is phase one. We want to be complete up to this point and be able to inhabit in this space while we continue on to phase two. And how do we actually solve that problem and do it right? And you can create these phases and assess it virtually before you're actually going out and doing it. So really nice there. This just sort of gives you an idea of how some firms may think about phasing. Again, like I said, they assign different years in terms of different types of floors, and what are they going to do in terms of construction. So pretty awesome. Again, collaboration. It's one of the only tools that I know of in design tools where entire team, even the client, can actually work simultaneously, all in the same file without any hiccups. There's no, hey, this other person's using this file, I can't even save it. It's like, so. All right, thanks, Robert. Have a good appointment, and we got a quick question from Robert, or comment, and he's going to run to a doctor's appointment. So, thanks, Robert. And this is recorded, so if you want to catch the last bit of it, you can always, I think, download it from John. And so, again, everyone can work on it. And so we are now at our case study. So basically, hopefully that gave you a good idea of the main things about BIM. We're going to look at a little video, and this fly-through is basically the guest house that I was talking about, fully modeled in Revit for GB Geotechnics when I worked there. And I'll tell you, almost every element in this exterior model, I had my hands on it. So you can just look at it and look at the details. Look at the little cupids or the cupid faces up at the top there. The little wrought iron, I think they're painted gold, but the little window covering ornaments, the doors, the windows. Right here in the front, you see the cupids with the little kind of wreath-like stone carvings there, the faces, the shields, all of that stuff purely in Revit. And then you're going to see the fountains there. So really, really amazing potential. The fact that that can be built to that level of detail in Revit is pretty amazing. And we got a quick question from Dorothy. Please recommend a publication that we can use to learn more about BIM. That's interesting. I don't know if I'm not a big publication reader, but maybe I'll have to get back to you on that. I'm not quite sure. I wouldn't have one that I could personally recommend in terms of learning more about BIM, but I can definitely say that if you ever want to talk to me about it, I'd be happy to talk all day about it, because literally this is mostly what I do. Is even as a consultant now, I'd say 75% of the work that I do still involves BIM, and it's getting more and more that way. I can imagine in a couple of years it'll probably be 90%. So I definitely would, though, take a look at other websites about BIM. There are a lot of BIM seminars that happen. BIM Forum is one I know of, and I know that USC has one that they like to do. Go to those, because really that's where I've learned a lot too. Not only by doing it, but by going to some of these seminars where people are really pushing the limits of it. It's really interesting to see, because it really sort of starts to get your mind sort of like, wow, there's a lot of potential there. Because if the one thing I don't like about maybe publications or maybe even just watching videos online is that a lot of the things that you'll see is very simple, and you'll see that there's a disconnect between that and a lot of the preservation work that I've actually been experienced to is you guys are working on like very ornate buildings that have details that were maybe hand carved by somebody, and you know, to look at some sort of rectangular box being built, there's just a huge disconnect. And so it may be that going to maybe seminars might be better. Hopefully, CPF might have some more interesting webinars that maybe discuss a little bit more about this kind of stuff. Um, but I would take a look in those areas first. Uh, and so we've got another question from Chris. Can you describe the process of using lasers or other equipment to create a 3D model? Absolutely. And basically, so the way that we currently use it, they have these things called laser scanners, and it's just a little machine that sits on a tripod, and it shoots out a laser. But as that laser gets shot out to the surface and it gets bounced back, it records that distance, and that distance in space gets a little point. And it does thousands of these, or millions, actually, billions maybe, of points. And it can do like I don't know, I'd say maybe a couple 100,000 points per second. So it does a lot. And basically, that information, because it's three-dimensional and it's in 3D space, I can take it into programs like Revit, and I can take it into programs that are native to that software, which is what we did. And from that, you can start to create mesh models, basically, where the software will basically create a triangle where 3 points lie, and that's a flat surface, right? And it'll create millions and millions of them. And as the density of the points gets denser, you can imagine those triangles get smaller, and they get so small that you no longer see anything as flat. Everything is curved. And so those kinds of three-dimensional models can then be further massaged, manipulated to really get to the most precise level, and then somewhat maybe simplified in order for programs like Revit to run efficiently. Because you can imagine if you had a lot of these elements in the model at full-blown infinitesimally small triangles everywhere, your computer's going to crawl to a halt. So there is a little bit of trade-off that you have to sort of still, you know, get a little bit looser, but I can guarantee you that you don't really actually necessarily lose quality, because again, in the reality is that if you're not going to see it, and also let's say you might be worried that I'm going to send this to a 3D printer, is that still going to, you know, be a problem? And I'll guarantee you it's probably not, because the precision of the printer is still probably like in the millimeter range, right? And these triangles are probably even smaller than that. So it's not going to be able to pick up any of that, and our eyes won't be able to pick up that either in the finished product. So I don't think that that's an issue, and that's kind of the way I worked. I think other people may have other ways, but when we were creating these very, very precise models, that was the best way to do it, was to look at the points and create some sort of mesh that fit the points perfectly. And again, because the laser scanner can only see what it bounces off of, multiple scans need to happen across the building. And there are areas where there are challenges where we faced where there wasn't a way to actually shoot down. So because like you can imagine the roof of the house or the tops of the heads of the statues, there's really no place for us to put a tripod to actually shoot down and get some kind of information from. And then at that point, it becomes a hybrid exercise of different techniques, photogrammetry, which uses cameras, and video, photos, and laser scan to finish fixing and creating, let's say, like the top of the head of the statues was a big one, because we wouldn't have any points there. So that's sort of one of the processes. And I think that CPF did have a recent webinar from another person from Microdesk, Peter Marchese, who talked a little bit about photogrammetry and how that, and I think that could also be a very good way to do this in the future, because we use laser scanners, but this was at a time where I think photogrammetry was still sort of a not necessarily a new thing, but it wasn't really developed to where it is now, because now they have drones doing that kind of work, which is pretty amazing. So it's always evolving, but there's always probably an infinite way to make 3D models, but that's the way that it was created here. So let's just take a quick look at the results. This is the house, again, all modeled in Revit with the same materials that we could try to approximate to our best knowledge from the site. These are visualizations taken directly out of that program. And just take a good look at how ornate this stuff can get, how detailed this can get. I mean, this little doorway ornate little ornament here that fills in the doorway is very complex, and it looks symmetrical, but it's not. And I probably spent a good 2 weeks maybe modeling this, but it has all the correct thicknesses, it has all the correct bends, because this was probably hand bent, and our job was to recreate what was there. So if you ever get a chance, or if I ever open this up again, you'll if you look very carefully and you try to mirror things, it doesn't work, because actually the left side and the right side, they're bent slightly differently, probably because they were all bent by hand. So really, really amazing potential. And take a look at the heads here, the faces of all the angels and cupids that go around. Again, this is the one of the fountains. Like I said, the resolution that you can get is really good, and this can definitely be taken to fabrication level. And things like the top of the heads here, we didn't have that information, but again, through various uses, various different methods, we were able to get something very accurate. So this kind of stuff taken out of Revit, pretty amazing. A little bit closer view of different statues. So each statue was different. This was a different pose, and again, modeled from point clouds, created from mesh geometry. And like I said, you can see it's got that sculpture-like quality. I mean, you can see the muscles and how they're flexing in the body on this statue. It's really, really amazing. So when you see these videos and you see people just making boxy buildings, don't get discouraged, because I can tell you, I created these, and so it is doable. So hopefully that gives you a nice little primer on BIM for historic preservation, and hopefully you guys see some sort of potential use for it. So I'm going to open it up for a Q&A at this point. If you have any other questions, please go ahead and give me your questions. I'm ready to answer them. Okay. Okay. Sure. Okay, we got one here from Chris. What are the for LOD 100 versus 400? I think it's quite a bit. Again, I wasn't part of the discussions when I was working at GBG, but I can tell you in terms of time that there's a huge difference in time versus LOD versus 100 versus 400. I would say a 100 model for like something like that guest house at Hearst Castle take, uh, for me it would take me a day, maybe less, maybe even a couple hours. But um, LOD 400 for that same house is like what, 6 months. So huge difference. And so you see most of the time in the industry, LOD 300 is the one that's chosen. It's a nice sweet spot. It doesn't give you everything in terms of fabrication level, but if that's not what you need, you may not need to go there. If you just need to know kind of what it generally look like, and you're okay with that, and that fits your budget and needs, LOD 300 is probably the best. And so I would imagine, let's say for the instance, to give you some reference, for that same guest house, if we wanted to do LOD 300 for it, instead of taking 6 months, I would assume that it would probably take maybe 1 month to 2 months at most. So huge difference. LOD 400 really requires a lot of time and effort.
Okay, that seems to be the final question. So I'm going to move over to the evaluation. I wanted to thank you, Joe.
All right.
And thanks again for all the time. All of our speakers are volunteers for CPF, so we really appreciate the time that they commit to this and the preparation. What you see here on the screen now is an evaluation page, and I hope that each of you can return your comments. It helps us improve our programs and also plan for future programs. In fact, our education committee is meeting this month to plan the 2015-16 programs, and your input will help us inform that calendar. And so on the top of the page are some links. If you need to sign in today, the sign-in link is on the top. Below that, you'll see a link to upcoming workshops and webinars that CPF is running. And then I also wanted to invite each of you to attend the webinar on July the 16th, which is a Thursday, which will look at modernism on the brink, assessing threats to modern buildings and landscapes, presented by Gretchen Hilliard and Andrew Wolfram. This session was one of our most popular sessions at the conference, and it's being presented for you again as a webinar. If you'd like to take advantage of it, you would use the all caps coupon code of CPF MOD or CPF mod to get $10 off that webinar and the following modernism webinar, which will look at modern landscapes. So we hope you'll attend that session. After today, you can register for either one of those sessions and receive the $10 off. And I'm going to email each of you some resources from today's webinar, but hopefully by the end of the day, including a link to the PDF if you haven't already downloaded it from today's PowerPoint. So as you leave these comments, I'm going to leave the window open, so please do leave your feedback for us. We look forward to having you at future programs, and please consider becoming a member if you aren't already a member of California Preservation Foundation. So thanks again, Joe, and have a nice day, everybody. I'll leave the screen up for another 15 minutes or so.
Great. Thank you, John.